Okay, so in this tutorial, we're going to start really leveraging the advantage of designing with code as opposed to designing with, say, pure modeling or parametric modeling in Grasshopper. So what we've got is a random generator. It creates random massings and booleans those massings together in certain ways. And there isn't any real design logic as part of this generator. As in, sometimes it makes some really large massings, sometimes it makes massings with kind of weird floaty bits that aren't, that are multiple parts. Um, let's say we have some constraints where we want the massing that is generated to be a certain volume. Um, we might want it to be, say, only one part. We might want it to be a valid Boolean, like it has to Boolean union everything together. These might be the constraints that we're interested in for now. And what we can do is we can tell our script, instead of just making a grid of options like this, and some of them will be good and some of them will be bad, we can start telling it to keep working on an option until that option meets some criteria. So we're going to try doing that now. What I'm going to do is, to make this cheap, I'm going to copy this code, or actually we can just go new chat here. So that's going to clear our chat history. And I'm going to switch this back to using Opus, good model. Make sure we're still on Rhino Python. And we're going to start saying, look, we need to implement some constraints here. We need to implement some constraints on our generated massings. For each massing, keep iterating up to 10 tries, let's say, or up to 5 tries. This is a video. We don't want to just be generating forever. And make sure the generated form is A over some minimum volume. Oops. And B, a single object. We don't want to create separate objects after the Boolean union. Okay, and we'll just hit go. So these good models like Opus, they're pretty good at following design direction like this. And what's going to happen is the model is going to work out, okay, so while I'm generating each massing, instead of just running my algorithm once and then finishing, I'm going to run it, then I'm going to evaluate what I made, and then I'm going to run that algorithm again and again and again until it meets the criteria. So this is super powerful. As long as you can define design criteria clearly in words like this, and that is actually hard to do, and your design criteria might just be purely visual or aesthetic. In this case, we're defining something that's easy to calculate. As long as you can define the design criteria, you can tell these coding agents to write code where they'll iterate on the generated geometry until it meets that criteria, and that's a really, really powerful idea. So Opus in the background here is running a whole lot of these string replace tools to go and edit this code to make it meet the constraints that we've specified. Okay, changed a lot of the code and we'll hit run. Okay, so it looks like minimum volume percentage of bounds is what it's added here to our UI, so we can actually specify what we want that minimum volume to be. Let's just hit generate and see what it gets. So now it's clicking through each one of these, and for each one it's checking that it's actually meeting the criteria. So this is kind of interesting. It looks like the main thing that's being done here is it's making sure that these are all single booleans. There's no floating geometry, and all of these ones here don't meet our criteria. So I guess probably what we can do is just increase the number of tries or decrease our percentage volume option. So let's try that. I'd like the number of tries to be an option in the UI. It seems like with default settings, we can't generate most massings. Let's tweak these defaults. Nice. So it has figured out pretty well. I think that's exactly what I would have done. We would have wanted to increase that overlap threshold because otherwise, a lot of the time, the massings just aren't touching, especially for that Boolean union. So let's see what we get. Okay, so it's gone and tweaked a lot of the code again. And we'll hit run. Okay, max retry is 10. That's definitely a lot higher. Doesn't look like we're changing our defaults. So I'm going to make that a little bit bigger as well, unless this is a scale over its default. Okay, cool. That's much better. So now it looks like what we're getting is a bunch of options where everything meets our criteria for being a single solid object. Everything is clearly over a minimum volume. We don't have those small floaty objects anymore. And we could go and actually start using some of these with subsequent steps. Like maybe now that we know that these are closed masses, we could start contouring them all and calculating floor areas and things like that, which we might really quickly look at in the next video.